Good afternoon, my students. Today we have to discuss about the first law of thermodynamics. We already discussed zeroth law of thermodynamics and other things about internal energy. Today we have to discuss about the first law of thermodynamics. First law of thermodynamics. First law of thermodynamics. This law was enunciated by Robert Mayer. Robert Mayer and Helmholtz. This law was enunciated by Robert Mayer and Helmholtz. This law is also called as law of conservation of energy. Law of conservation of energy. This law is also called as law of conservation of energy. Actually, the first law was given first by the Hess in 1840, but due to some difficulty, Hess is a Russian man at that time, so Russian chemistry. Due to some defects, it was not accepted. After that, Robert Mayer first. Robert Mayer in 1842 was first enunciated the first law of thermodynamics. Robert Mayer, his father is a pharmacist, but he do not like the chemistry. He is actually a physician and he studied about medicine. But he find out that in 1842 the first law of thermodynamics, but he did not prove it experimentally. The experimentally it was explained by Helmholtz. It was explained by Helmholtz in 1847. In 1847, Helmholtz explained it, but it was first given by 1842. Robert Mayer, he is actually studied medicine. His father is a pharmacist. He is a German. He is basically a physician, but he announced it in 1842, and this law is called as the law of conservation of energy. According to him, energy can neither be created, energy can neither energy can neither be created nor destroyed, but it can be converted, converted from one form, FORM, from one form to another form, FORM. This is the statement of the first law. This statement was first given by 1842 by Robert Mayer. Actual name is Julius Robert von Mayer. Actual name is Robert von Mayer. Before that Julius, but popularly they are called as Robert Mayer. So this law was given by in 1842, and his first paper was published in 1841. Some other related, not with this first law, but 1842 he enunciated this law. 1847 it was explained by the Helmholtz. But what is the justification of this first law? Justification is that the perpetual motion machine cannot, it was completely impossible, but it is completely impossible to construct a perpetual motion machine. That means According to the first law, it tells that energy can neither be created nor destroyed, but it can be converted one form into another form. When we cannot create energy, we also cannot destroy the energy, but one form is converted into another form. Suppose anything else, you can convert it into heat. Anything else, by friction, by magnetic, by electric, you can convert into heat. Heat can be converted into work. But it tells that we cannot destroy energy, we also cannot create energy, but one form is converted to another form. In the same manner, how it is justified is that it is impossible to construct a perpetual motion machine. Impossible perpetual motion machine means the machine which does work without consuming any energy. That means perpetual motion means it does work, it does work without consuming, without consuming any energy. Without consuming any energy, a machine will work. That means any instrument you can invent it, if it do not consume energy, then it is called as the perpetual motion machine. So it is impossible totally in that we cannot construct a perpetual motion machine. Second thing is that James Joule experimentally found that experimentally found experimentally found that 1 calorie of heat 1 calorie of heat is produced for every 4.184 joule of work in the system. That means if you carry out 4.184 joule of work done on the system, that means when you do work on the system and the work amount is 4.184, then 1 calorie of heat is produced. Or when work done by the system, if system will do work itself by losing energy of itself, then 4.184 joules, suppose it does some work, then 1 calorie of heat it lost. That means for every 4.184 joule of work done, 1 calorie of heat is required. That means whether you work done on the system or by the system, if your work done is 4.184 joule, then 1 calorie of heat is lost if the work done by the system. If you work done on the system, then 1 calorie of heat is produced. This is according to the James Joule. It is experimentally proved. Then third point is that 68.4 kilocalorie of heat is required for 1 mole of water to undergo decomposition. Decomposition means you have to break this water. So in order to decompose the 1 mole of water means 18 gram water. 18 gram water you want to decompose, 68.4 kilocalorie of heat is required. Or when 1 mole of water is produced, when 1 mole of water is produced from hydrogen and oxygen, then 68.4 kilocalorie of heat is evolved. You know that bond formation energy release, for bond breaking energy required. So this is the 68.4 kilocalorie of heat is required to decompose the water in order to break the bond. If I want to produce 1 mole of water, that means 1 mole means 18 gram water from hydrogen and oxygen, then 68.4 kilocalorie of heat is evolved. This is the justification of the first law. How the first law is justified. So in 3 ways you can justify that it is completely impossible, to construct a perpetual motion machine. Perpetual motion machine means the machine which does work without consuming any energy. James Joule experimentally found that if 4.18 joule of work is carried out, then 1 calorie of heat we have to produce. When it is system work done by the system, then 1 calorie of heat is required. When 1 calorie of heat is evolved, when 4.184 joule of work is done on the system. Third point is that when you want to decompose 1 mole of water means 18 gram water, we require 68.4 kilocalorie. If you want to prepare 1 mole of water, that means 18 gram of water, then 80 calorie of heat is evolved, because bond breaking, in this case bond was breaking, so heat is required. In this case bond is formed between hydrogen and oxygen, so this amount of energy is released. The first law of thermodynamics can also be stated in terms of mass and energy, that the total mass and energy, the total mass and energy, the total mass and energy of an isolated system, is remain constant, but unchanged, is remain constant or unchanged, not change. Previously whatever is there, then after that also same thing, total mass and energy. If mass is decreases, energy will be more. If energy decreases, mass will be more. So total mass and energy, if you compare before and after, it will be remain same in an isolated system after doing work, or after doing working on the system, or work done by the system. Before and after, total mass and energy will remain same. That means if mass decreases, energy increases. If energy decreases, mass increases. This is also the first law of thermodynamics. Then how you mathematically express the first law of thermodynamics? Mathematically how you express? Mathematically you have to express mathematical expression. We know that we are very familiar of writing this type of equation, dq is equal to du plus del w. We are very usually when anyone asked me write down the mathematical expression of first law, then we can write such type. But you can write any way, you can write in different way, because in physics people they require some cases about, in case of delta w they write something else, and because they use non-SI system. As in chemistry people use SI system, the sign is different. But you always remember that, you always think that, first thing that case 1, how you write the first law of thermodynamics. Let the internal energy of the system initially is U1. U1 is initially it is U1. Let work done by the system, so first we draw this diagram, it is better, then it is easy to remember whether when it is negative, when it is positive, because it is very essential. Suppose work done on the system, this is our system, work done on the system, it is positive. Work done by the system, negative. Heat supplied to the system, positive. Heat given out from the system, negative. This is important. First we thought, let initially the system has internal energy E1. Internal energy means total energy stored in a system. Let work done on the system. Work done on the system. That means you do work on the system. You have to do work on the system. You have to do. So it is positive. So W is positive. Let heat supplied to the system. Heat supplied to the system. You have to supply heat to the system. In this case, Q is positive. Let the change in let the change in let the internal energy of the system is U2. U2 means initially it is U1. Now you work done on the system. You have to do some work on the system. You supply heat to the system. In that after work done on the system, heat supplied to the system, then internal energy will be now converted to U2. Now your total internal energy U2 is equal to U1. Initially it was there. U2 is the total internal energy after operation. Initially U1, work done on the system, W is positive, heat supplied to the system, Q is positive. Now what is the change in internal energy? We know that absolute value of internal energy cannot be obtained. So U2 minus U1, you take left hand side, this is the change in internal energy is equal to W plus Q. Change in internal energy means delta U is equal to Q plus W. In this way also you can write the first law of thermodynamics. Whatever is that first law of thermodynamics, mathematically you write like this, but remember why you have to mention everything else. Delta U you can write change in internal energy, Q is the heat supplied to the system, W is the work done on the system. You have to mention these two things. You have to mention this also. Otherwise, first law of thermodynamics is not valid. First law of thermodynamics can be written in different way. So this is the first case we have to see. Then second case is that how we can write. First we draw this diagram, otherwise it will be a mistake. When work done on the system or by the system, work done on the system, double positive, work done by the system, double negative, heat supplied to the system, Q positive, heat supplied out of the system, Q negative. That means any means system's energy increases means positive. Any means system energy decreases means negative. Case 2. How we can write the first law? Case 2 is that let the initial internal energy U1, let initially it was in there, let work done by the system, work done by the system will do some work. System do work means system loses energy, that means it is negative. W is negative. Work done by the system will do some work, system's energy decreases. Let heat supplied to the system, heat supplied to the system means Q positive. Can heat you supply the system's energy increases, so it is positive. Let the final internal energy is equal to U2. Final internal energy means after operation. Initially it was U1. Work done by the system will do some work. When system will do work means system's energy decreases. System's energy decreases means negative. You supply heat to the system, that means system's energy increases, so Q is positive. After work done by the system, heat supplied to the system, final internal energy is U2. Then what is my final internal energy? Now U2, initially it is U1 plus heat supplied positive, work done by the system negative. Now we take what is the change in internal energy, because we cannot find out absolute value. U2 minus U1 is equal to Q minus W. So that is equal to delta U is equal to Q minus W. This is the second way you can write the first law of thermodynamics. You can write this formula also, but remember you have to always mention delta U is change in internal energy, Q is the heat supplied to the system, W is the work done by the system. Without mentioning, if you write this equation, then it is nothing. That means it is meaningless. So you can write case 3. How can write in this way also? Let the initial internal energy is U1. Let work done by the system. System will do some work. By the system means negative. Let heat evolved from the system. Heat evolved from the system. From the system, heat is evolved. System means Q is negative because system's energy decreases. Heat evolved, work done, double negative. Let the final internal energy after operation, final internal energy is U2. U2 is the final internal energy. Then total internal energy U2 is equal to initially U1 work done by the system negative, heats evolved from the system negative. This is the final internal energy. We know that absolute value we cannot determine. So we can determine only change one U2 minus U1 minus W minus Q. This is equal to the change in internal energy. Delta U is equal to minus W minus Q. In this way also you can write the first law of thermodynamics. But remember, once again I tell you, you have to mention everything else. Delta U is the change in internal energy. Minus W means work done by the system. Minus Q means heat evolved from the system. Case 4. Let the initial internal energy is equal to U1. Let work done on the system. Work done on the system. Work done on the system means double positive. System's energy increases. Work done means system's energy increases. Heat evolved from the system. Let heat evolved from the system. Heat evolved from the system. Heat evolved means system's energy decreases. System's energy decreases. Heat evolved. So Q is negative. Let the final internal energy is equal to U2. So then what is I can write U2 is equal to U1 initially there plus W work done on the system. So system's energy increases minus Q heat evolved from the system. System's energy decreases. Then change in energy U2 minus U1 W minus Q. Then that was the change in internal energy. Delta U is equal to W minus Q. In this way also you can write the first law of thermodynamics. But you have to mention delta U change in internal energy plus W means work done on the system minus Q means heat moves by heat evolved from the system. So in this way you can write down the first law of thermodynamics mathematical expression. Nothing is wrong, but you have to mention everything else. Without mentioning the first law of thermodynamics, whatever you can write in mathematical form, it is completely wrong. Because plus W minus W plus Q minus Q both are path dependent function. So it is needed for its convention because these two are path dependent function. So we have to mention its sign and we have to mention what it indicates. That was why in 4 different way you can write the first law of thermodynamics. So next is we can write the enthalpy. Next is we can write the enthalpy. Enthalpy, H symbol. Enthalpy is heat content in a system. Heat content in a system at constant pressure and temperature. Or you can write also the total energy content in a system that is available to do some work, or that is available to convert into heat, that is available to convert into heat. The amount of energy stored in a system that is available, that is available to convert into heat, that is available to convert into heat. This is also enthalpy. Enthalpy generally we can write that H is equal to U plus PV enthalpy. That is, suppose pressure is constant, suppose initially enthalpy is H1, ये है internal energy initially U1, pressure is constant, initially volume also V1. So finally suppose after operation, after माने process is over, enthalpy is H2, internal energy है U2, pressure is constant V2. Then what is the change in enthalpy? Now H2 minus H1, then we get U2 minus U1 plus P V2 minus V1. That means delta H is equal to delta U plus P delta V. This is called the enthalpy. Then what is the characteristics of enthalpy? Characteristics of enthalpy. First is that enthalpy is an extensive property. Enthalpy is an extensive property because it depends upon the quantities of matter present in the system. Enthalpy depends upon the quantities of matter present in the system. Suppose 10 gram substance, 10 gram water you consider. Whatever the enthalpy is not equal to 100 gram of water. In 100 gram of water, enthalpy will be more than that of the 10 gram of water. So enthalpy changes with change in mass. So enthalpy is an extensive property. It depends upon the quantities of matter present in the system. Enthalpy is a state function. It is a state function because it depends upon initial state P1, V1, T1 and P2, V2, T2, initial state and final state. It is path independent function. Path independent. It does not depend upon the path. Path independent. Does not depend upon the path it follow. In which path it occur, it does not depend. But it depends upon the initial state and final state of the system. Then fourth is, it is an exact differential. It is an exact differential. I already told you in case of internal energy, that means if you integrate H1 to H2 delta H, when you integrate H2 in minus H1, first upper value, then lower value, then is equal to delta H. But absolute value of enthalpy cannot be evaluated. The absolute value of enthalpy, the absolute value of enthalpy cannot be evaluated. Like internal energy internal energy also absolute value cannot be evaluated. In this case also absolute value cannot be evaluated. Change in enthalpy can be evaluated. Change in enthalpy can be evaluated. Enthalpy change can be evaluated, but absolute value cannot be evaluated. Hey, Musa, ja, saya Musa गुड़ाक कि हे ना ମୁଁ ଅଟୋମେଟିକ୍ କରିଦେଇଛି, ଅଟୋମେଟିକ୍ କରିଛି କି ନାହିଁ କିଏ ଜାଣି। ହଁ କାଲି ତ ଥିଲା। So change in enthalpy can be evaluated. Change in enthalpy can be evaluated. So this is all about the enthalpy and how it is mathematically expressed. Delta H is equal to delta U plus P delta B by delta N RT. Then in the significance of enthalpy, we can write that what? Now delta H is equal to delta U plus P delta B, or we can write delta H is equal to delta U plus delta N RT. These two way you can write. Suppose case 1, suppose delta V is positive. When? Now when final volume and initial final volume minus initial volume value should be positive, or delta N is positive. When? Now number of mole of the product minus number of mole of the reactants should be greater than 0. That means positive. In that case only, that means initial volume V2 minus V1 is positive, means suppose this is my system, this is my piston, this is suppose initial volume V1. When system do some work, means this piston will move upward. Suppose this piston will move to this distance, and this distance is equal to V2. Then V2 minus V1 is positive. Then work done by the system will do some work. That means it indicates that delta in this indicate that delta V positive, delta N positive, means system will do some work. That means work done by the system will do some work. The example is, suppose PCl5 gas convert into PCl3 gas plus Cl2 gas. Here is all gas mole, 1 mole, 2 mole, minus 1 mole, 2 minus 1 is equal to 1 mole. So it is positive. So in this is the example of where the system work done by the system. Second case, suppose delta V negative, that means V2 minus V1 is negative. That means V1 is greater than V2. So that means what happens? Now if this is the system, this is the volume, initial volume is V1. So when we do some work on the system, we apply pressure, then what happens? This piston will move to this side. This is the final volume. That means when V1 minus V2, we always need final volume minus initial. Always take final minus initial. V2 minus V1. This will comes negative. That means work done on the system. Example is, suppose N2 gas plus 3H2 gas we converted to ammonia gas. Here you see delta N is number of mole of the product, 2 mole, minus number of mole of the reactant, 3 mole plus 1 mole. 3 plus 1 is equal to 4. 2 minus 4 is equal to minus 2. Delta N is negative, 0. Delta N is less than 0. That means it is negative. Negative means work done on the system. Last case, when delta V delta V 0 or delta N 0. In this case, no pressure volume work, no pressure volume, no pressure volume work we can carry it out, because V1 is equal to V2. That means this is my system, this is the V, this is also V1, the same thing also V2. Then we get delta V0, V2 minus V1 0. Delta in example is, suppose 2HI undergo decomposition, H2 gas plus I2 gas. Then what is the delta N? Number of mole of the product, 1 mole, 1 mole, 1 plus 1 minus 2. 2 minus 2 is equal to 0. So in this case, no pressure volume work. Okay, next class we have to do some. Next class we do heat capacity. Today this much is. ये रमजान महीना है, होली का मंथ. खुदा हाफिज.